So today we are going to be talking about factoring polynomials. In a minute we're going to talk about what is factoring and how will we do that. Today we will be using a GCF to factor. But before we do that, I just want to do a little review of the distributive property because what we're going to be doing today relates to the distributive property. So for the first problem, hopefully you've already done the notes on distributive property review. We're going to distribute this A to both parts of the parentheses. Remember, when you multiply, you add exponents. So a times 3a will give me 3a squared because both of those a's have a 1 as an exponent. So 1 plus 1 gives me 2. That's why it's 3a squared. A times 7 is just 7a. For the second one, I'm going to distribute negative 2m to everything in these parentheses. So to the m squared, to the 6m, and to the negative 1. So negative 2m times m squared would give me negative 2m cubed because the first m has a 1 and the m squared has 2. 1 plus 2 is 3. Negative 2 times 6 gives me negative 12. And then m times m is m squared because, again, they both have an exponent of 1. 1 plus 1 is 2. Negative 2 times negative 1 is positive 2. And then m, no m, so we just have 1m, so positive 2m. And then the last one I'm distributing is 5xy to both the x and the negative 2y. So 5xy times x would be 5x squared y because I have a 5, 2 x's, so x squared, and a y. Then 5 times negative 2 is negative 10, 1x, and then y times y is y squared, so 2y's. Okay, so now let's talk about what is factoring. Factoring is when you break down a polynomial, so this would be considered a polynomial, when you break them down into its prime factors. Basically what we're going to be doing is undoing multiplication. Today the one we're going to be undoing is distributive property. So I'm going to get, the problems are going to look like my answers looked previously. I'm going to get a problem that looks like this, and my solution is going to look like this. So I'm going to be working backwards from the distributive property. I'm going to take out a factor. So I'm undoing multiplication. If a polynomial cannot be factored, there are no common factors, there's nothing I can factor out, that is called a prime polynomial, meaning it can only be divided by 1 or itself, just like a prime number. Now there's several ways to factor. Today we're only learning one of those ways, and the way we're doing it today is the greatest common factor of the polynomial. So first off, a greatest common factor. The first thing you're going to do is find the greatest common factor of the coefficients or the big numbers. Then you're going to see if you have any like variables in all terms and see if you can factor those out. So it's kind of the opposite of distributive property. A common factor is something that can be divided into every term. Greatest common factor means it's the biggest thing that can be divided into all of the terms. So when I look at 3x plus 12, 3 divides into 3, 3 also divides into 12. So 3 would be my greatest common factor. So what I do is I figure out what my greatest common factor is, in this case it's 3, and I divide each part of the polynomial by that 3. Then what I do is I write the common factor on the outside of parentheses, and then I write what I got when I divided on the inside of those parentheses. So my final answer will be 3 times x plus 4 because 3 is my common factor. 3x divided by 3 gives me x, and 12 divided by 3 gives me 4. So I'm basically taking out the 3 to the front. If I were to redistribute, 3 times x is 3x, 3 times 4 is 12. So it's just the opposite of distributive property. I'm taking out instead of putting in to the parentheses. So there's my final answer. All right, so for number 2, both terms have a 7, so 7 is my greatest common factor. So I divide each thing by 7. I put the 7 on the outside because that's the greatest common factor. And inside I write what I got when I divided. So 7y divided by 7 gives me just y. And negative 7 divided by 7 gives me 1. So my final answer is 7 times y minus 1. When I look at my next problem, the greatest common factor that goes into both 5 and 30 is 5. Now they have variables, but there's an x in this term and a y in that term. They don't match, so the only common factor is the 5. When I factor out the 5, I put the 5 on the outside of the parenthesis, and then I divide each part by that 5. So 5x divided by 5 is x. 30y divided by 5 is 6y. So 5x divided by 5 gives me the x, and 30y divided by 5 gives me 6y. So that's where those came from. So your final answer is 5y parentheses x plus 6y. Okay, for the next problem, I have an 8m and a 36n. So again, the variables don't match, so I'm only going to look at the numbers. 8 does not go into both 8 and 36, so 8 cannot work. But the number 4 goes into 8 and into 36. 2 also divides into both, but remember, we're looking for the greatest common factor. So 4 is bigger than 2, so 4 is my greatest common factor. So 4 goes into both 8m and 36. So we write our 4 on the outside of the parentheses, and then I divide each term by 4. 8m divided by 4 gives me 2m. 36n divided by 4 gives me 9n. So that's my final answer. Okay, so now moving along to number 6. I'm going to skip number 5 right now. I'm going to have you go back and look at it in a minute. For number 6, I have a 4 and a 24. So the greatest common factor for my numbers is 4 because 4 goes into 4 and into 24. But notice I have a y squared and a y. I have y's in both terms, so therefore y is also a common factor. When you have variables, the greatest common factor will always be the smaller exponent. So if you think of it, this factor has 2 y's, but this factor only has 1 y. So I can only take 1 y from each factor because that's the most that this one has to give. So you take the smallest of the exponents. So my greatest common factor would be 4y. A 4 because that's the greatest common factor of the numbers, and a y because that's both terms, have a y, and the lower exponent is 1, so 4y. So 4y goes on the outside. Then you need to think about your dividing rules to get what goes on the inside of your parentheses. 4y squared divided by 4y. So 4 divided by 4 is 1. Y squared over y. Remember, you subtract exponents. So 2 minus 1 gives me 1. 24 divided by 4 is 6. And the y's cancel out. So it's just a 6. So that's how I get my final answer of 4y times y minus 6. Now remember, you can always redistribute and make sure you get back your original problem to make sure to double check that you got the right answer. 4y times y gives me 4y squared. 4y times negative 6 gives me negative 24y. So that does work. Okay, so let's look at number 7. First, look at your numbers, 21 and 3. The biggest number that divides into 21 and 3 evenly is the number 3. Now, the first term has a C, but the second term does not have a C. So therefore, C is not part of my common factors. However, both terms do have a D, and they both only have one D. So my greatest common factor is 3D. A 3 is the biggest number that divides into 21 and 3, and D is the lower exponent because they both are 1. Excuse me, there's no C because both factors do not have a C. So if I divide 21 divided by 3 gives me 7. The D's cancel and I'm left with only a C, so that's where 7C comes from. Minus 3 divided by 3 is 1, and your D's cancel out. So divide both parts by 3D. Okay, I want to scroll down to ones that are slightly more complicated. So let's look at number 9. If I look at my numbers, 15 and 30, 15 divides into 15 and into 30. So that's going to be the number. They both have an A. The lower exponent on A is just 1A. They also both have a B. The lower exponent is just 1B. So my greatest common factor is 15, A, because that's the lower exponent between 2 and 1, and B because they're both a 1. So 15AB. There's an A and a B in both terms. When I divide, 15AB goes on the outside of my parentheses, my GCF. On the inside is what I get when I divide. 15 divided by 15 is 1. A squared divided by A is A. B divided by B cancels out. Minus 30 divided by 15 is 2. The A cancels and the B cancels, so that's why it's just a 2. Looking at number 10, it's very similar to number 9. I have 16bc squared plus 24bc. So looking at 16 and 24, the greatest number that divides evenly into 16 and 24 is 8. They both have a b, and they both have c's. The lower exponent on c is c squared. So my greatest common factor is 8bc. When I divide that out, I bring my 8bc to the outside. 16 divided by 8 is 2. The b's cancel. C squared over c is c. 24 divided by 8 is 3. The b's and the c's both cancel. 11 and 12 look a little different, but they're still pretty much the same idea. There are no numbers, so I just look at my variables. What do I have in common? I have an A in both terms, so that's my GCF, is A. When I divide AB over A, the A's cancel out, and I'm left with a B. A divided by A gives me 1, because anything divided by itself is a 1. So I put my A, which is my GCF, on the outside, and then B minus 1 on the inside. The GCF for 12, what do they have in common? They both have X. The smaller exponent on X is a 1, so it's just 1X. They do not both have a Y. They do not both have a number, so only X. X squared, so X goes on the outside. X squared divided by X gives me X. 3xy divided by X, all that happens is the X's cancel, so I'm left with 3y. If you move over to the back, we're going to skip down. Whenever you get a problem that has more terms than 2, it's still the same idea. You think, what's the biggest number that divides into all terms, and what is the smaller exponent if the variable's on all? So look at number 17. All terms, the biggest number that divides into all of them is 2. They all have a y. The smallest exponent is y squared. So 2y squared is your GCF. Then divide each part by 2y squared. 6y to the 4th divided by 2y squared. 6 divided by 2 is 3. Y to the 4th over y squared is y squared. 14 divided by 2 is 7. Y to the 3rd over y squared is 1. Negative 10 divided by 2 is negative 5. Y squared over y squared cancels out. So that's how you get your final answer. We did not have time to go through every problem, but you have in your email and posted on Edmodo the solutions to all of the problems. So make sure you check those answers and try all the rest of the problems. If you have questions, make sure to come to my office hours.